Saxon's Calculus, Lesson 72, is about critical number theorem, but it's critical number on a closed interval, so they put that in parentheses. Now, we have already talked before about the maximum and minimum, but they're giving us here the maximum minimum value existence theorem. So in this first box, if f is defined and continuous on a closed interval from a to b, then the function attains a maximum value and a minimum value between those points. They would be the end points is what they're trying to say. One of them will be the max value and one of them will be the min value. Then we move to the critical number theorem, sometimes called the closed interval theorem. And it says if a function is a function which is defined and continuous on a closed interval that they call I, and if the function attains a maximum or a minimum value at a certain place they're calling C, then C has to be an element in that set interval I. So one of three things is happening. C is an endpoint, the derivative of C does not exist, or the derivative of C is 0. All right, so now that you have all of that lovely wordiness, over in example 1, it says find the maximum and minimum values of an equation on the interval from -2 to 4. So what I know is that -2 and 4 being the endpoints are two of the critical numbers that might give me the max or the min. But I need to take the original equation, which was f of x equals 2x cubed minus 3x squared minus 12x plus 1, and I need to derive it and set it equal to 0 to find the other critical numbers. So that's going to give us 6x squared minus 6x minus 12 set equal to 0. So everything can divide by 6, leaving us x squared minus x minus 2 equals 0, because 0 divided by 6 still 0. Now can I factor that into two parentheses? And if I can't, I'll have to do the quadratic formula. Whoops, 1. So negative in the middle, so the 2 needs to be negative, it's the higher number. How do I go from -2 to -1? I would add 1. Positive times negative is negative, perfect. So then my answers here are -1 and 2. So adding those to the list, 1 out of those is the maximum and 1 out of those is the minimum. So we need to plug them in to the original to see what we're getting. So it's a lot of math. Again, much faster on your calculator. So -2, that's going to be -8, -16, +4, minus 12, plus 24, plus 1, 26, -28, so -4. All right, so -2 should be giving me -3. Okay, now let's plug in 4. 16 times 4, 64 times 2, 128. 16 times 3, 48. So 128 minus 48, 80. Yeah. All right. Minus 12 times 4, 48. So minus 48, 32. Plus 1. So when I plug in 4, I believe I'm getting 31. All right, now let's plug in -1. -1, so that's -2, -1, +1, minus 3, plus 12, plus 1, -5, 7 was 8. And now plugging in 2, 8, 16, 4, 12, 24, 1, 4, negative 20, negative 19. Okay, now let me check against their answers. Negative 2 gave negative 3, yes. Negative 1 gave 8, yes. 2 gave negative 19, and 4 gave, oops, I did have an error there. It should be 33. Somewhere you will have found where I made my mistake as I did it, or your calculator would have given you the correct answer. So now, which one gives me the highest value? Well, that's the 33. So this one becomes my max at 4, and the smallest one is the negative 19, so this one is the min. And let's see, the 4 came from one of the endpoints, but the min point came from the other solution somewhere in between. All right, example 2. A 10-inch long string is cut into 2 pieces. One of the pieces is bent to form a square and the other to form a circle. So a picture here is helpful, and the book gives you one, but they're basically saying I'm cutting a string, and on this one, when I fold it, I'm creating a circle, and on this one, when I fold it, I'm creating a square. Oh, that looks more like a rectangle. All right. And if the string was 10 inches, and if I call this side x, then this will be 10 minus x left for the length of that one. Okay, pieces, form a square, form a circle. Find where the string would be cut so that the total area of the circle and the square are at their maximum. So we need to find, so the circumference formed the x, and circumference is found by doing pi times diameter, which would be equaling the x. Debating if I want to put that in its radius format. Yes, because ultimately we're heading to the maximum area. So I do, instead of writing this one as diameter, I want to write it as 2r. So to solve for the radius then, I would be getting the radius is x divided by 2 pi. With that lower, that was messing with my head a little bit. So now the area would tell me pi times this radius squared is its area. Okay, now the square part, all sides are the same, so 4 x's has to equal the 10 minus x. I want to solve for a side. I need the side so I can get the area. So that means solving for, I'm going to change this to an S for sides. I feel like that's going to be, the 2 different X's made it feel like it was the same number, and I knew it wasn't supposed to be. So now the side will be 10 minus X over 4. And to get its area, we're going to take that formula times itself. So 10 minus X over 4 squared is its area. All right, and then together, those areas should be added. And I need to create a max. And I know I have, it can be anywhere from 0 at the start to 10 at the end. I feel like I need to simplify this. So to simplify, this becomes x squared. This becomes 4 pi squared. However, this pi up here cancels with one of these, so it's gone. So I just have x squared over 4 pi. Then this one has to multiply by itself. The bottom part is easy. 4 squared to 16. 10 times 10 is 100. 10 times the negative x is negative 10x, doubling to negative 20x plus x squared. Can't reduce all of those. They don't have common denominators. And I need to integrate to find, not integrate, derive. I need to derive to find maximum value. Okay, so this 1 over 4 pi is acting as a constant. 1 over 4 pi. Then I pull the 2 down from the x squared, multiplying this by a 2, and making this x. So that should give me x over 2 pi. Okay, yes. All right, I'm going to go ahead and simplify that. And I'm going to write the x in front, not on top. Yes, x over 2 pi. Okay, plus, then 10 over 16 reduces to 50. No, it can go higher than that. 4 and 25. Okay, that's reduced, but it's my constant, so when I derive, it doesn't matter, it's gone away. Okay, minus 20 over 16. Now that's reducing to, by 4 again, so minus 5x over 4. X squared. No, I'm getting integration and derivative. After you do it so many times, it's easy to start flipping them. So negative 5/4 and losing the x. Got it. Now the last one is x squared over 16. So I don't care about the 16, I did it separate. So this one is plus 2x. Now, they pulled the x out of these two and left 1 over 2 pi plus not 2. Well, the minus 5/4 I definitely match with them on. Is this? How is that one having a problem? It's having a problem because I said don't do the 16 because I already wrote a 4 here and that was completely wrong. So this should have originally been x squared over the 16. So then when I pulled the 2 off, it went to 2 over 16, which reduces it to 1 over 8 with the x. That explains where their parenthesis with the 1/8 x comes from. So I have the 3 parts. They've just changed it by pulling the x out of these 2, which I don't know whether that's helpful or not. Okay, so where were we in this process? Yes, finding the max. So we need to set equal to 0. Oh, yeah, I see why they're pulling their x out. Okay, so let's write these two together. And I'm going to write this as 1 over 2 pi. I'll go ahead and separate it. Plus 1/8 x equals, and now it's positive 5/4 when I move it over. Since my goal was to solve for x, that's why they went ahead and factored it. So we're going to divide this, which means flip and multiply. So that needs, before I do that, it needs a common denominator. So that should be 8 pi. This one's missing the pi. This one is missing a 4. So when I flip it, it's 8 pi over 4 plus pi. Yes, okay. Now, at this point, they shift gears and change it to a decimal, which would be very smart because this is super messy at this point. So then 5 times 8 times 3.14 divided by 16 plus 4 times pi. Anyway, they're saying it should come out to approximately 4.4. And you may round yours slightly differently. Okay, so now we know we have our endpoints that could be our max value. Now, it's seriously not going to be 0 because that's no maximum value. It could be the 10 or it could be 4.4. Now that we know all of that, we should technically plug in and find out what answers we get. Now, even though I know 0 isn't it, if I plug 0 into, and I gotta find the problem, where I originally added the areas. So if I plug 0 in, that one goes away. This one, 10 4 squared, 100 over 16, that's going to reduce. So they're saying in decimal, that's 6.25. When they plug in 4.4, they get 3.5. And again, I'm not even going to attempt to do that on paper, all calculator work. And then plugging in 10 gives them 7.96. So comparing 7.96, 3.5, and 6.25, so it's funny, their 4.4 is actually lower than their 0. I would not have expected that. So then that means that the best one to use is the full 10 to find the maximum value at 7.96. 7.96 at 10, I guess, would be how I would answer that. Example 3. Find the maximum and minimum values of f on an interval between -2 and 3. Now it listed them that way. If f of x is x to the 2/3. So we need to derive giving us 2/3 x to the, now minus 3/3, so -1/3. Okay. And technically then, if you simplify that, it becomes 2 over 3x moving down to the positive 1/3 in the denominator. Okay. I can't have x being 0 in the denominator because that would cause me to have an undefined. So in other words, if I try to set this equal to 0, I have a problem, is what we're saying there. So even though plugging 0, if I plug 0 in up here in the original, I get a 0. So 0, 0 is a point. I would then need to, so this doesn't help, the derive didn't help give me anything other than 0. Then -2 plugged in would be I'm squaring it and then trying to cube root it. But the cubed root of 4, decimal, do this in decimal. So 2 gives 1.59. And then plugging in 3 gives 2.08. And again, you want to test all of that on your calculator to make sure you have that working. So what does it look? Oh, the max and the min. So 2.08 is the largest. So that is going to be your maximum. And the minimum, of course, is 0. I was struggling to understand why they wrote the answer the way they did, but doesn't matter. Example 4. A function is continuous on the closed interval of -2 to 4. Such that f of -2 is 2, f of -1 is -1, f of 4 is 5. Okay. Also, the derived formula and the double derived have properties that are given in this table. What do they want? Oh, find the values of x for which f obtains the maximum and minimum values. Describe any points of interest. Okay. I'm debating, is it better to graph this or just try to think your way through it? I think it is probably best to try to graph it. So I know that I am bounded between -2 and 4. At -2, I got a value of 2. That's from here. At -1, I got a value of -1. And at 4, I got a value of 5. Let's just throw it up there. Okay. So I don't really know what's happening in between here. Now let me check the rest of what they told us. Okay. In the first derivative test between -2 and -1, it's negative, meaning it has to be falling. Well, that I would have guessed just based on what the dots were doing. And x equals -1. At this point, it does not exist, so I've got a 0 slope here, basically. Then between -1 and 2, it's positive. Okay, now I know I'm climbing up to wherever this dot is. I might guess a dot up here, and I know I'm climbing toward that, okay? Then at x equals 2, I know I've got, again, a slope that's 0, no matter which way it's going. And then between 2 and 4, it's also positive. So it's climbing from 2 to 4. Maybe I'll put this dot closer up here. Okay. It might be one full swoop, but I don't want to assume that quite yet. And I have some more information to work through. So on the double derivative between -2 and -1, it's negative. So it's concave down. All right, so most definitely concave down. Yep. Then I don't have at 1 between -1 and 2. It's negative. Okay, it's also concave down, so I need somewhat of a swoop like so. Now, between 2 and 4, it's positive. We're concaving up, so there's a swoop in there somewhere. Okay, what does it want? Oh, max and mins. So my lowest point is at -1. So there's my min. My max is clearly over here at the 5. Talk about answers bleeding into each other. Absolute maximum at the 4. And then it said, talk about any other places where something might be of importance. Well, that would be at this dot here. It's an inflection point. I don't think I see anything else. Let me just make sure. Inflection point at 2, we are able to sketch the function, obtain the maximum. Yeah, we're good.